Well, good morning, everyone, and thank you very much for joining our webinar on 8000 series I/O solutions for replacing older I/O. I'm Leo Charpentier with NovaTech, and I'll be your host this morning. I wish I could see all of you because I really much prefer to be in front of a crowd than be staring at a computer screen when I do these presentations. I can't read your facial expression, and I can't tell if any of my jokes work this way. Chris Coriolis has joined me in the room. I'm using to do the presentation, and he'll be monitoring for questions as we go. I'd like to cover a few webinar logistics to get started. Everyone will be muted during the presentation. If you want to ask questions, just do that in the question section of your webinar toolbar. At the end of the presentation, Chris will be feeding me questions to answer. You can use a microphone. You can use your speakers or voice over IP or your telephone. You do that by make the changes to that selection in the audio section of your webinar toolbar. So I'm going to dive right in. So what are we going to cover today? We're going to cover briefly an 8000 I/O overview. Just going to cover some of the key points of 8000 I/O for those of you who aren't familiar with it. Then I'm going to go into proven upgrade procedures. I've moved this to the second item today. In the past, when I've done similar presentations, I've kept it to the end. But after reconsidering, I think it's important to go through the procedures before we go into the technology and the methods. I'm going to cover two different methods of converting quantum I/O to 8000. We're going to then talk about 16,000 to 8,000. So quantum and 16,000 we'll cover in more detail. The last three items, 505, Modicon 200, and Allen Bradley 1771 I/O, will cover more quickly and briefly. So let's get started with an overview of 8000 I/O. 8000 I/O is NovaTech's native I/O. It is a DCS-I/O family. And I say that, and I've been saying that for 20, 30 years about I/O that goes with the D3. From the 16,000 I/O was DCS-I/O. The quantum I/O actually was DCS-I/O because NovaTech engineers worked with Modicon in the design of that I/O family and put in a lot of capabilities we had in our 16,000 I/O into the quantum I/O. But what does it mean? What it means is the I/O is designed to work with a distributed control system. A distributed control system is an integrated entity. So you do everything from the distributed control system as opposed to, buying an HMI from one person, buying an I/O from somebody else, buying a controller from somebody else, buying a trending package from a third person or alarm package from a fourth person. The distributed control systems are integrated. You have all your tools together. So there's two parts of saying something is DCS-I/O. One is the physical I/O itself and its characteristics. So this I/O, for example, is conformally coded. It's designed to go into plant. It's got extreme temperature ranges of -40 to +70. And it has a lot of capability down to the channel level. So for example, we can get reports on over and under range on a channel basis. We get open circuit detects. We get all sorts of diagnostics on a channel level. Okay, you say, well, I can get that with some PLC I/O, and yes, you can, but this is where you have to look closely for some of the differences. Some of those things are only available at the module level. Some of those things, like over and under range, the values that count for over and under could be on a module level, could be on a system level, but are rarely on a point level in less expensive non-DCS type I/O. The channel-to-channel isolation, the types of modules that are available, whether it's field-powered or module-powered, those types of things, again, as you go to less expensive I/O, you often have fewer options in those choices. So when you're looking at I/O families, don't look just at price, look at the level of the capability in the I/O, and look down there at individual channels, and that's probably where you'll see most of your differences. This I/O is also fully integrated into the D3. It is the most integrated I/O family NovaTech has ever produced. With ProcessVision console, is tied directly in. You can see the status of every I/O point. You can see the status of the host system and its graphical status configuration. Diagnostics are built in on some of the status displays. You can see the actual points going down in the I/O modules, and the integration, the configuration of the 8000 I/O is fully integrated in the D3. You just have to define a point, an EPN and model, give it the address for the 4 to 20 or the signal or the field signal, and NovaTech takes care of getting you all the rest of the information. All the alarms associated with that point, they're all transparent to you. They just show up associated with the tag. Again, in I/O families that aren't as integrated, you would have to put those individual addresses of the alarms into the system. So that's why we say that 8000 I/O is a fully integrated DCS I/O family for the D3. So is there a future to 8000 I/O? Yes, there is. 8000 I/O is manufactured under an OEM agreement by GE for NovaTech. It's being used currently at greenfield and brownfield sites, and it's being used for expansion installations throughout the world. It's fully supported by GE, and GE has no plans to mature this I/O. And to bring some proof to that, anybody can make that statement, but I'd like to offer you concrete proof to that. GE is continuing to invest heavily in the 8000 I/O product line. In 2016 and 2017, there's a program that is currently underway for redesigning the I/O to RoHS compliance, which is a requirement for selling the I/O in Europe. What does that mean? It means that at the end of 2017, when the full rollout of RoHS compliance is done, all modules and all circuit boards in that 8000 I/O are going to be current designs that can be manufactured using up-to-date modern components, because only the more modern components meet the RoHS compliance. We're also doing some product enhancements, including a new 32-point field termination assembly, so we can use a 32-point digital module. As part of RoHS compliant, the EBIM and the EBIM carrier are also being redesigned, and they're going to be a smaller form factor going forward. NovaTech has made a commitment to supporting 8000 I/O through 2035. Get my math right, I think that's another 18 years, isn't it, Chris? Yeah. He's nodding his head. So, in addition to the standard capabilities that you would expect in most I/O families, the 8000 I/O has a few you may not be expecting. First one is it's HART capable. We have HART capable modules at a reasonable price over the non-HART. They're about $100 list price more than a non-HART module. And we're able to bring in the 4 HART variables that can be defined for each HART point and display them in the same manner as you would display your 4 to 20 milliamp signal. In addition, we monitor every HART communication to the D3. There are some statuses that we monitor. One is a warning status from the instrument, and the other is a failure status from the instrument. We bring those in to the D3 and alarm on them for every point, every HART point in the system that is enabled. Now, for those of you familiar with HART, if you want to get the same capability with an asset management package, you probably have to buy something called condition monitoring, something else similar, and they charge on the point basis for that. Very expensive. We give it to you for free as part of our HART interface. You don't know what the warning is, but that's where the asset management software capability comes in. And you can run asset management software like FieldCare or ASM right through the D3. You put it on a server or on a computer connected to the D3 I/O network, and you can drill down to that instrument using the FTM, DTM capability and explore that instrument to your heart's content, find exactly what those warnings, alarms really mean. But also, 8000 I/O also has a full complement of intrinsically safe I/O. So, and you can put intrinsically safe I/O in the same rack with standard 8000 I/O. So, no need for barriers anymore. You can put your standard 8000 I/O, you put a rail bus isolator in, and everything after that rail bus isolator can be intrinsically safe. So you can mix and match in the same rack. You can put one intrinsically safe cabinet right next to a non-intrinsically safe cabinet, your choice. But it's built into the D3, simplifies things and reduces cost dramatically. We also have a kind of a unique feature in the process control world. Nobody else has this capability, and that is NovaTech introduced 1 to 6 module redundancy. And this can be defined on a per carrier basis, 8 carrier. So here you see a standard 8 carrier with 8 modules. The first 7 modules in this case are the same type of module, and the 8th is a DI/DO module. Below that is a NovaTech design component that consists of a backplate and then individual relay modules for each slot. And in simple terms, the way this works is the I/O signals come in here on this ribbon cable from a termination block. They normally pass right through the back of the circuit board into the FTA and go into the module. If a module fails, the EBIM will note the failure of the module. It looks to see if the module in slot 7 is of the same type and is not being used. If it isn't, what it will do is it'll move the configuration, copy the configuration from the fail module to module 7. After that's done, it sends a digital output to module 8, which opens a relay, or closes the relay, and flips all the relays on this card. What that does is it sends the signals from the input field across the card into module 7. Module 7 has now replaced module 1, but as far as the control system is concerned, other than alarms and status indications, none of your application programs know any different. And the switching is so fast on any point on the module that had not failed, it doesn't interfere with, it doesn't interrupt your operations at all. The heart signals ride right through it. You go out, you send someone out to the field, they replace the module, and they push a switch, I believe that's it there, on the card, and that signals the EBIM that they're ready to swap back. The EBIM kind of reverses things and swaps back. We say 1 to 6 because any of these first 6 modules can be replaced by the 7th, so long as they're the same type. But if you only needed to provide redundancy for 2 modules, you could have 2 analogs inputs here, matching 7th module, and these other 4 could be something else. And the system is smart enough to know that only these 2 modules would be provided in the 1 to 6 redundancy. So in that case, it's 1 to 2 redundancy. Get my ratios right this morning, guys and ladies. So what does it look like when you put the 8000 I/O with the rest of the D3? This is a sample architecture picture of a D3 system. We're going to focus down below E0 and E1 on the I/O side. You'll notice that we have PCM 4200s, 4100s, and PCM 5s. You need one of these 3 types of PCMs with 8000 I/O. The way it works in a redundant system, you have an A and B micro. Each A and B micro has an EMPC2 card, which its own switch. And let's just call the switch on the left the A switch and the switch on the right the B switch. So we have A and B networks, I/O networks. The 2 switches are connected together by an interland link so that you can go from PCM A to switch A across the interland link to switch B, and now you're on B's highway. The way this dual redundant Ethernet communication works, as I mentioned earlier, it's the most fault tolerant we've ever introduced. It tries to minimize the impact of failures. So if EBIM A is talking to PCM A, and it can know over network I/O A, and PCM A can no longer talk over the A network, and it sees that it can talk over the B network, it will start communicating to PCM-A over the B network through that interland switch. If it cannot talk to PCM-A over either of its networks, A or B, then the EBIM and the backup EBIM can talk to PCM on either A or B. It will switch to the backup EBIM. The backup EBIM, which now becomes the master, will talk to PCM-A over the A network. If it can't talk to it over the A network, it will talk over the B network. If neither EBIM can communicate with PCM-A, but can communicate with PCM-B, then the micros will switch. So again, we minimize the impact first by just switching cables, essentially, then by switching EBIMs, and finally, as the last resort, switching PCMs. And this arrangement can survive multiple failures. You can have breaks in different segments of your Ethernet and still never lose communication because of the ability to route through those switches. This is far superior to what we have in quantum, for those of you with quantum I/O. So what's a rack of 8,000 I/O look like? Well, a rack of 8,000 I/O looks similar to other I/O families. There are communication cards. In this case, they're called eBIMs. They can be single or redundant. They're mounted on carriers, either a redundant carrier or a simplex carrier. Each one has dual Ethernets, as I mentioned. Each one also has a power supply monitor, so we can monitor the status of the power supplies. They connect with a connector, or you can use a cable to connect it to 8 module carriers. Carriers are available that control 8 modules. And you can have up to 64 carriers together, connected either one next to each other, like down here we show 2 connected together, or connected with cables in between. There is a limitation of 21 feet for rail bus length, and that includes the length through all the backplanes and all the cables. So in designing your I/O setup and cabinets, you have to be conscious. If you want to run a lot of I/O together, you want larger cabinets so you can put more racks together. If you have to run a cable between cabinets, you have to take into account the length of the cable, for example, to go from the end of the I/O rack down to the bottom of the cabinet, across to the next cabinet, up into the beginning of the next I/O rack. So just be cognizant that, as in any bus system, there is a length limitation. In this one, it's about 21 feet. You can bring in field bus power to the carriers. There are 2. Each connector powers 2 carriers, and you can daisy chain the power between the connectors. We generally do that. We power so many modules on a circuit breaker or a fuse, and we then power additional modules. That allows you to mix 24-volt power, for example, to some modules, and 124 volt to other modules on the same carrier. You just have to know that it's powered 2 at a time. NovaTech also designs and manufactures I/O cabinet. We actually have a pretty good business going here in our assembly area, about a couple hundred yards from us, and we manufacture a variety of cabinet designs. This is a common one that we're using today. Power comes in, 120 volt power, 220 volt power comes into the cabinet at the right here, and it goes to, from that point, it goes to redundant 12 or redundant 24 volt power, and redundant 24 volt power supplies. They go out through circuit breakers, they power the eBIMs, they power the network switches, and the only place you have AC is up in this corner unless you have AC field wiring. We then have in this case, looks like 4 carriers of 8,000 I/O. Those carriers are factory wired to terminal blocks in these rows below them, and you can see the wiring going up through here and into the carriers. We factory wire all that to the terminal blocks. The factory wiring goes in one of these channels, and the field wiring, which you can see is not connected to the other side, goes up the other channel. So we segregate the field wiring from the internal cabinet wiring. If you need additional fusing, the fusing are in the terminal blocks. If we need relays to power older equipment or high current low equipment, those relays are in the terminal blocks. That's just one of the designs. We have other designs. These are a variety or sections of cabinets showing a variety of designs with different power supplies, power supply monitoring, fiber optic switches. Depending on what your individual requirements are, we will create a design or modify an existing one that meets your needs. We also do stainless steel enclosures and enclosures that are conditioned for harsh environments, or being located out there in the weather. So please talk to your NovaTech account representative if you're thinking about doing cabinets. One of the nice things about NovaTech doing your cabinet is we know that 8,000 I/O inside and out. We know how to connect it, and these cabinets are tested all the way through to a D3 system before they ship from the factory. That's something a local cabinet supplier won't be doing for you. So let's talk about some of the integration of the D3 I/O. So you are looking at, some of you are saying, oh, that's a total vision graphic. No, that's not. That's a ProcessVision status display. You don't do a single thing to create this display. You don't have to do anything. Well, you do. You have to configure 8,000 I/O, and you have to assign it to EPNs in your model database. But once you've done that, the system takes over from there. On the left-hand side of this display, there's a tree hierarchy. We're looking at Ethernet adapter Ethernet EMPC card 0 in this case, and it is showing that there are 2 eBIMs connected to this Ethernet card. Each eBIM has 2 communications. I'm sorry, there are 2 drops associated with this card. The first drop here, the left eBIM is the master, the right eBIM has failed, and the second drop. It automatically, isn't that right? It automatically, when you select the eBIM, which is the second one here, the one that's blue, I believe, is the selected one, it automatically looks at that eBIM and finds out how many carriers are connected to it. So it knows there are 3 carriers. It then looks and finds out what modules are connected to those carriers. And it shows the modules. And those are graphical representations of what you would see out in the field of the module. That red module has failed. And it shows it very visibly in this graphic. There are lights on those modules, and believe it or not, those lights actually mimic the lights that are in the field. So you can at a glance look at your I/O. This is great for your instrument people, not only for your operators, but it's wonderful for troubleshooting. And again, you didn't do anything to do this. It all comes with the ProcessVision console. You can take that down to a next level and look at an individual module. And thanks to some feedback we had from some customers when we were first implementing 8000 I/O in these ProcessVision displays, there's all sorts of information available. For example, I know that these 4 gray points at the bottom of this module are not configured in 8000 I/O. And I know that because they're gray. This 4th point, this red one, which indicates the point has failed, I know there's no EPN associated with it because there's no number. And that kind of leaves you the rest. 1, 2, and 3 have EPNs associated with them. 2 and 3 are good, and 1 is red, it's failed. If we look at the detail on the right-hand side of the display, oops, sorry, I'm looking at the wrong screen for my mouse. You'll notice that channel 1 is in high alarm, so that's the problem with it. You'll notice on the right-hand side, look at that last column. That column is EPNs. Okay, so this is a first, something people have had to do for themselves for a long time. You want to go out and replace that module, and you are concerned, what are you going to shut off when you pull that module? Well, you don't have to look up in model. You don't have to, the operator doesn't have to call a control engineer. He just calls up this screen, and he'll see the EPN, or she'll see the EPN for every point that's on that module. If the point is used in more than 1 EPN, all the EPNs will show up on that list. That really simplifies maintenance of this system. This is a heart module. So not only are we showing the I/O channel, the wiring, we're showing the 4 heart points defined for this module, and we're showing them. We're showing with their values. We're showing if there are EPNs associated with them. All automatically done. All right, that's kind of the 8000 I/O overview. I can talk a whole lot longer at 8000 I/O, but I don't have the time, so I'm not going to. So let's talk about proven upgrade procedures. It's important. Doing an upgrade is a complicated procedure. It's important to get it right. You want your plant to come down and come right back up and keep on running, making you money. So we have procedures that work. The first thing is you need to determine the scope of the upgrade. And we do that working with you while we do a site survey. We meet with you and we talk over what it is, what your objectives are. We look at the existing system, and based on what we're able to find out during the site survey, we determine what are feasible upgrades. Some of the things to consider is, are we going to move the I/O wiring from the existing terminations to new terminations? We're going to do a solution that involves interface boards and keeps the wiring in place completely. Do you have to upgrade a PCM? The 8000 I/O requires the new PCM 5s, PCM 4200s, or PCM 4100s. Is there space in the existing cabinets to put the 8000 I/O in the eBIMs? Are you going to need additional space? Are we going to reuse existing cabinets and perhaps add additional cabinets? Are you going to configure the database, or do you want NovaTech to configure the new database and conversions? Are you going to be doing this portion of the plant at a time? Are you going to be able to take down, for example, a boiler and its PCM and upgrade that while your other boilers are running, and then bring that back online? Or is this going to occur during a complete plant shutdown? Give an example. We've done complete upgrades. I personally was at one in Mexico where we did 33 I/O cabinets over 2,700 I/O points, We had the first I/O turned back over to the plant, and also PCM upgrades and server upgrades. I mean, it was a complete upgrade from 1996 to 2015. We had, in about 2 days, we had the first I/O cabinets turned back over to the plant, and they were starting to check out that I/O. In 7 days, all of the I/O was turned over to the plant. That is feasible. That can be done based on our experiences. So, site survey, and I'm not going to apologize for it. I'm going to use this word throughout this presentation, so get used to it. Each upgrade is unique. You can't take a cookie cutter approach doing the upgrade. You can't even take a cookie cutter approach in some plants. We've been in plants where 30 cabinets are all pretty much identical design, look like they were when they were installed, hardly touched. We've been in other plants where every cabinet or every rack of I/O is different. And we had places in between where there's 2 or 3 different rack designs. Sometimes this stuff was put in all at the same time. Sometimes over the last 30 years, the plant's gone through a series of expansions, and each expansion took a slightly different approach. So we've got to go in and look. And doing that harder engineering time at the beginning makes this a better project for all of us. We have more accurate time and material estimates. We know what we're doing. We're able to come back and custom design assemblies and mounting plates that will simplify and speed up the installation time and the checkout, so that it can all be done more quickly. We also send experienced and skilled NovaTech personnel for these changeovers. So anything that might have been missed during the design stage, wasn't documented, or didn't find it, they can generally solve these problems in the field and get them solved before you get into the commissioning stages. Here are some samples of some of the custom design panels. This top one over here on the left is 2 carriers of 8,000 I/O with a left place to cable it in from the left. You'll see there are breakers on top that connected to the field bus wiring, the 24 volts or wiring going to the field. All mounted on an aluminum plate. This is for a quantum replacement, and that aluminum plate and the whole positions are all designed to fit into the place of the existing 16 module quantum I/O rack. Here's an 8,000 I/O E-beam carrier and a right edge connector, again mounted on an aluminum plate to fit into, match the holes already in the backplate. We try to minimize having to drill any holes in backplate. As all of you who know know I/O well, know that you never want to get metal filings, and if you don't have to drill a hole, you don't. So this example down below was that job in Mexico, and to support the weight of this rack, we didn't have any holes at top, so we made a bracket that just slipped over the top of the backplate, and that provided the top support, and then we were able to screw the rack down. Here's another rack that contains power supplies and E-beams, and even has room for a spare. So all of these racks are all connected and tested in the factory, and we use some of the latest test equipment available. For example, this piece of equipment that I photographed in our factory floor today, I don't know that you can all read that, but that's a Heathkit designed device. And I hate to say it, but I'm old enough to have built a vacuum tube voltmeter with a Heathkit design and an amateur radio transmitter a long time ago. So those of you who may be my age, you might remember this stuff, and the rest of you with antiques you've seen in the used electronics shop, but this is not used today. This looks more kind of like what some testing goes. I took this picture this morning too. So this is what you call an up to the minute presentation. This is some I/O racks being tested right now, going to be shipped out soon to a customer site to replace some quantum I/O. And you can see the test setup. We have a number of racks here. You can see the E-beams mounted on this vertical panel that are going with them, and the power supplies. You can see a D3 keyboard connected to a D3. And as I said, this I/O is being tested all the way through D3 with a database, and that's the D3 off to the side. We've also done other types of testing. This is a testing for the cabinet that's in Mexico that I showed you earlier. So this top rack, in this case, holds the E-beam, some switches, the I/O carrier that replaced the quantum I/O, and these are 12 and 24 volt power supplies mounted on aluminum panels, and the holes in the panel are exactly match the holes that were there for the existing power supplies that they were replacing. So again, all good engineering design up front to minimize time and installation and ensure success. What are your upgrade requirements? They're actually pretty simple. You need a D3 version 12.2 or higher. Even though it says later that it was introduced in 12.1, we made some changes to 12.2, we need 12.2 or higher. You need a PCM 4100 or 4200, and if you have one of those, you need an EMPC2, the Ethernet board that goes in to talk the Modbus TCP protocol that is used as 8000 IO protocol. Or you need a new PCM5 when they're available later this year, and it has built-in enough Ethernet built in, so there's no extra Ethernet board required for it. You'll need to convert your database. For 16,000 IO, we have a highly configurable utility that allows you to convert 16,000 databases easily. A little complicated, but anybody can learn how to use it, but you might just let NovaTech do it because we've done it enough times that they don't have to learn. They know how to do it. Everything else, manual conversions, again, we've got a lot of experience doing that. Believe me, after you've done it a few times, you get to know how to do it faster and faster. And some of our engineers have that experience. Okay, so what's the actual upgrade process? And this applies to any of the upgrades that we're going to be talking about today. You as a customer need to meet with your NovaTech account representative and talk about it and schedule a site survey when we can send out an engineer and field service people to your site to look at your equipment, talk to you, find out what your requirements are. Coming back out of that site survey would be a list, location, physical information, dimensions, sizes of all your existing equipment that you're going to look at replacing. We measure hole distances. That's how we're able to make those aluminum plates for those power supplies and the rest. And we'll photograph as much as possible because we don't remember everything. And being able to look at a photograph we come back helps. And if we can't tell from the photograph, we may be emailing you back or calling you up and going out and having you take some measurements for us. We analyze all that information and we come up with an upgrade approach that makes sense for your site and what you're trying to achieve. And from that, we do a quote. And the quotes are generally quite accurate because we've done this preliminary engineering. When we receive your purchase order, that's when we start actually doing the detailed hardware design, designing any plates or anything else that's necessary. We generate the drawings, we requisition the material, we get things fabricated, and we start scheduling the project. As material is received, we start building it up in the factory. We build up, add the components to the assemblies, we wire as much as possible, we get shipping containers designed or sometimes custom foam so we can ship these things all in ready. Database gets converted, we mentioned that. Then we do the testing as I showed in some of the pictures. If you purchase the FAT, you're welcome to come on in and watch us doing the FAT. The next stage is the system is packed, shipped, delivered, waiting for installation at your plant. We'll send a team out that works with your guys and gals, and we go through the installation. We like to get your people need to be involved in the installation. The more knowledgeable you have for controls and instrumentation people at the plant, the easier this is going to go, because they know, especially if they've been there a while, they know your system, they know your hardware, they know your electronics, and they're invaluable during the installation. So let's talk now about an actual conversion method. So the first one I want to talk about is converting quantum IO to 8000 IO. So I'd like to start off with a little bit of history and some future of quantum. Quantum was introduced in 1994 in D3 version 7. The first IO was delivered to Cargill's Blair, Nebraska Greenfield site to the tune of about 30,000 IO points. We actually delayed the introduction of quantum IO and quantum PLCs into the Modicon channel by over 6 months because we had bought out the entire production capacity. And just like any first run, I can tell you, because I was there in North Andover numerous times in the factory, we kept on pushing to get this stuff in because we had our customer had a deadline, and we lit a fire under Modicon to make sure that we met those deadlines. For a reference point, 2006, we introduced the 8000 IO. We worked with what was then MTL company to OEM the 8000 IO and introduced some things in there that we needed. MTL was later purchased by GE. In 2013, NovaTech announced that the MROC board, that's the board inside the PCM that talks the S908 interface to Modicon, was entering the repair and replace status because the MROC chip was no longer available. In 2017, just this year, this may be news to some of you with Quantum I/O, Schneider has announced the end of commercialization of quantum products. That means at the end of the commercialization period, nobody will be able to purchase new quantum products from Schneider. You might be able to still find some from people who may have stocked them, but Schneider will no longer be manufacturing or selling them, putting them into their distribution channel. The first product that gets affected by that is the CRA 93101. That is a communication module that sits in the quantum rack, talks to the MRIOC board. That will no longer be available for purchase from Schneider after December 31st of this year. So those of you with Quantum I/O and continue to do Quantum I/O, you need to go in and take an inventory of what you have and decide whether you have enough CRA modules for the end of life of your quantum system. And if you don't, you need to purchase it. That is a CRA 93101 is a unique module for NovaTech. It's not used by any other quantum systems. So a lot of Quantum I/O modules and parts are probably going to be available on eBay for many years to come, but you won't find many 931s. The only ones that are going to be showing up on eBay are the ones that people take out of your sites and put on eBay, because it's only NovaTech that use those. The rest of the Quantum I/O line, including everything, connectors, every part that they make, reached its end of life in 2021. So I give you this information now so you can be thinking about it and planning what you're going to do with your existing quantum until it is replaced. There are two solutions that we're going to present. The first one is rewiring the I/O module. I'm going to go into this a little more, and I'm actually going to speed things up here. I know I'm running a little late, but we'll speed things up when we get to the second part. Once again, site visit. We've got carriers and mounting plates and other things designed. We'll redo designs as necessary based on the information you find in your site visit. E-BIMs, we have to look for a place to mount those E-BIMs. A lot of times there's space available in the existing cabinet. Sometimes we have to move things around to make a little space. And if there's not space in the existing cabinet, we generally can locate them in another cabinet nearby, or even put in an additional cabinet if required. We basically are going to go in and we're going to fold down the quantum edge connectors, get them out of the way. We're going to pull out the Quantum I/O rack and all the modules. We're going to put in that panel with the 8000 I/O on it. We're going to put in a panel with the E-BIM on it, the network switches and the other things. Replace 12 and 20 volt power if necessary. We'll then go start wiring the quantum edge connectors, and we'll take a few wires off of the edge connector at a time, wiring to the FTAs on the 8000 I/O. We have documented procedures for every type of Quantum I/O module that we've done, and its respective 8000 I/O module that basically tells the person doing this, you pull it off of screw number 3 and it goes on screw number 4 on the FTA or what it is, right down through. So in all the jobs we've done this, we've had a really very minimum errors in any of the wiring because we have this procedure down so well. Depending on, again, there's no cookie cutter, so depending on your installation, you may require, and the modules that you have, it may require some additional 8000 I/O carriers or some alternative wiring like custom termination blocks that we've also designed for jobs. So that's part of the site survey. Here's an example of a cabinet before rewiring. This is a Quantum I/O cabinet, and this was from the project in Mexico. And you can see the Quantum I/O rack. That box on the top left is a surge protector. Now that one we replaced with a new surge protector and put it basically where the circuit breaker was. And the S908 interfaces are gone. So when it's completed, and before it was finally dressed, so the wiring is not the way the wiring was left when we left the plant. But here you see the 8000 I/O in place of the Quantum I/O, and you see the backplane, and then you see the E-BIMs in place of the equipment that was at the top, and new power supplies are on the left. So preparation for shipment. I'm not going to read all this, but basically everything that can be assembled in the factory is assembled in the factory and tested and shipped together. How's that for making that slide go fast? On site, kind of covered this already. We basically go in and replace the I/O. This is kind of a summary of what we did, because this presentation actually has quite a few more slides that I've hidden. And so after this Before the end of the month, we'll send you a link to the presentation. You'll have all the hidden slides as well, and now you'll know why I have summary slides. So we actually have a time-lapse video taken that shows in about 1 minute removing the equipment out of a cabinet and installing the new stuff. Except the video doesn't play very well over the internet during this broadcast webinar. So I just have a couple of stills. So here's a guy that's already taken that excess equipment out of the top and is now actually pulled down the quantum edge connectors and is now removing the quantum I/O rack. Depending on the site, sometimes we'll have a team of people who go through and do all the removal, followed by a team of people who come in and do the installation. Sometimes they start off doing the removal, and by the time after everything's removed, they move into the role of doing the wiring. We just find that speeds things up and reduces the amount of training when we are supported by additional local people. Here he is taking out the quantum I/O rack, and you'll notice that he's got all the quantum I/O modules still in it because he actually took out some screws that held the module. He put the modules back to keep everything neat. Here he is adding the Phoenix contact power supplies on the left-hand side in place of the 1996 power supplies that were there. You'll notice the quantum I/O modules terminations folded down. This is Scott Mitchell, a NovaTech employee that is in the process of moving wires from quantum I/O edge connectors to FTAs. Looks like he's got about 4 modules done and has some more to go in that rack. And that video, again, we'll have that video available so you can download it and play it. It's really kind of neat, and it gives you a really good sense of what's involved in a replacement. Summary. Okay, so what does this approach do? It replaces your existing quantum I/O with modern Ethernet 8000 I/O. It preserves the field wiring to the cabinet. It does require that you wire from the quantum edge connectors to the 8000 I/O. And it may require for some wiring that you have to replace the terminal blocks. Most of the time we find you don't, but there are some where we need to put in relays that you would have to replace the terminal blocks. It minimizes additional electronics. There are really no additional electronics, just replacements. It minimizes cables and connectors. The other 3 things are going to be on all the slides. Basically sets you up for another 15 or 18 years of good I/O and reliable service. So the second method of doing quantum I/O is using transition cards. This approach preserves most of the field termination because we do use the exact same quantum edge connector. We not only don't disconnect the field wiring, but we don't have to disconnect the edge connectors as well. So that saves a step that speeds up time in the plant. What it basically looks like is this is a kind of a photo picture diagram of it. So we have the quantum edge connector down here with the field wiring connected to it. Well, in case the field wiring is either directly connected to it or it's coming through terminal blocks. We have a transition card that the edge connector is connected to. The field card is connected in the factory with cables to 8000 I/O. That corresponds to the I/O being replaced. These termination cards does all the signal conditioning necessary to convert the signals into a form that can be used by the card. So maybe there are 120 volts coming in, but there are 24 volts quantum I/O modules that we're talking to. So they're going through a relay from 120 volts down to 24. If you look at a rack, this is a rack without showing the edge connectors. This is a prototype. I do need to mention that we have designed this solution almost to completion, but it's only been prototyped. We have prototype boards that we've gone through several iterations and tested. Customer has yet to purchase it. So when the first customer purchases it, we'll commercialize it. So the quantum edge connectors will plug into the edge of these boards and be screwed down. The rest of the rack arrives like it is, except all put together from the rack and secured for shipping from the factory. The boards, these are photographs of the actual boards that we have designed. There are a lot of different I/O modules. We have boards designed and prototypes made for the most common ones used by our customers. And we have to do an inventory as part of that site survey, find out exactly what boards you have, verify that we have transition boards available to meet that. And if not, look at either designing them or substituting with something else. Basic installation approach is kind of similar, and that we assemble things on the I/O basis and test as much as possible in the factory before shipping. Summary. Summary is very similar to the other one. This replaces all your Ethernet I/O. It preserves all the field wiring, including the wiring on the edge connector. So that results in minimizing the installation time because we don't have to do any point-to-point wiring. It also minimizes the need for I/O checkout because we haven't lifted any wires out of those. We're using the same edge connector. Basically, all you have to verify is that one of those points is the correct point on the card, and you're pretty much done. But it does add cables, connectors, electronics. It keeps the existing edge connector in there, though that's a simple device. But it does add more electronics and could complicate troubleshooting in the future. So that's the downside. So if you need something done very, very quickly, this is faster than doing the rewiring, but it does add additional components that you'll have in there for the life of the installation. All right, 16,000, 8,000 I/O conversion. As you notice, I've sped up a little bit because a lot of this is repetitive because we follow the same kind of procedure. History again, 16,000 was introduced in 1982 with D3 version 1. Throughout its life, mostly between 83 and 2003, we re-engineered the I/O several times in some modules, some parts of it more than once, so that we can continue to manufacture it as components became obsolete. 2013, 31 years after its introduction, NovaTech announced the 16,000 I/O was entering the repair and replace status because we could no longer get some parts, and it no longer made sense to re-engineer the I/O. So some of the I/O, some of the 16,000 I/O components we did last time buy, some of those we've actually run out of and no longer have. Some we have limited parts for repair and replace. So converting it, you've got PCM 1, 2, and 3 cabinets all using 16,000 I/O, and there are differences between them. And we have solutions for all 3 types of cabinets and the termination panels used in PCM 1, 2, and 3 because they also have changed. So basically, we stay with the termination panel architecture. So there are new termination panels, the one shown at the bottom right, to work with 8,000 I/O. And instead of 5 volts, for example, on 16,000, in some places the 8,000 I/O uses 24 volts. We keep your field wiring preserved. Your field wiring enters the cabinet and lands on screw terminations. And from screw terminations, there are cable harnesses that connect to these termination panels. There are 4 connectors on the bottom of each one. So basically, you go in, you pull out your existing, you pull off the 4 cable connectors, you take out your existing termination panel, you put the new one on, you connect the 4 cable connectors to it. Kind of hard to screw it up because the wiring is all dressed so the cable connectors only can go on the cables can only go on the connectors within reach. You need these termination panels the same way we did in the 16,000 I/O. They take care of the signal conditioning, they take care of the load. The MUX cards that are in the 16,000 are basically replaced by the 8,000 I/O modules. Kind of a schematic. Again, as I mentioned, there are a lot of hidden slides, so there are slides for every type of termination panel and I/O in this presentation to provide you all the information that you need to help configuration. It's a reference document, but I'm only going to show this one, and it basically shows a termination panel with the wiring to mass terminations on an 8,000 I/O module. So again, very hard to screw this up. Your point-to-points are not really going to be needed. Just need to make sure that you can talk to the module and it talks to one point out there and it's going to talk to all the rest. Some examples of going into a PCM 1 cabinet. We're mounting the I/O vertical. There is a drop from 70 degrees C to 50 degrees C in a vertical mounting of the 8,000 I/O. This I/O is all mounted on aluminum panels that are designed. You pull out the existing things, you put in these aluminum panels, they screw to the frame, and the I/O comes all mounted on these panels when it's shipped to you. Same thing for E-BIMs and switches. They'll get mounted on panels that just get bolted into the existing cabinets. Here's an example of a PCM 1 cabinet with 4200s from the top and 2 sets of E-BIMs below the cabinet to replace the existing electronics that were in that cabinet. Here's a hose side of a cabinet full of the new termination panels for 8000 IO. PCM2, slightly different design, different physical design of the cabinet, requiring different physical design for the panels that contain the 8000 IO and the E-BIMs. So here's a picture on the left that has E-BIMs and 8000 IO, and a picture on the right that just has 8000 IO. And you can see where this will just, you pull out the existing stuff and bolts into your 19-inch rack mounting your PCM2 cabinets. PCM3 cabinet, swing frame design, for those of you who have it, the one picture on the left is the door closed in the front of the swing frame. We've got PCM 4200 mounted there. We've got an E-BIM carrier. We've got some IO. The two pictures to the right are taken in the factory while we're doing assembling and testing of panels that were destined to go into a PCM3 cabinet. The one on the left has the E-BIMs at top, and the one on the right has 12 and 24 volt redundant power supplies. 505, this is going to be short. Not much 505 left out there, but we do have a 505 transition card replacement solution. This is similar to the transition card replacement for Quantum. In fact, the Quantum design was based on this one. We take either 505 terminations. There are two different end connectors, and we can handle both. There are 6 IO interface boards. I'll list them on the next slide. You basically mount this chassis in the place of your 8000 IO. I'm sorry, in place of the 505 IO, you do have to find a remote location for mounting the 8000 IO modules, because there's not place in an existing cabinet for both the transition panels and the 8000 IO modules. These are the 6 modules that we support for 8000 IO, and will work for you if you have any other modules that are different from this to find a solution. Modicon 200 upgrade, you thought the 505 was fast. This is going to be even faster. Modicon used to make this connector. You might be able to find them on eBay. It connects to the 2000 series IO basis, so your field wiring stays in place. You put that connector on, and that connector is wired to 8000 IO FTAs. Simple. Allen Bradley 1771. There's a lot of Allen Bradley 1771 out of there, and we have a solution to upgrading your 1771 IO. And those of you who like the Rockwell's Allen Bradley Rockwell solution to converting 1771 to control logics, you'll love the NovaTech solution. That's because we didn't reinvent the wheel. We're using some components that we purchased from Rockwell. So the top right picture is a base. That base assembly, base plate replaces your chassis of 1771 IO. You take, similar to doing Quantum, you take the edge connectors off, you fold it down, you put the chassis in. The second picture are, guess what? Transition modules developed by Rockwell for transitioning from 1771 to control logics. It has a 25-pin connector. We are using those. We didn't reinvent it. However, we did reinvent the cables, because the cables from Rockwell connect to control logics, and our NovaTech design cables connect to 18,000 IO. And that's a sample prototype cable shown at the right. This picture kind of in the middle shows the whole thing put together. There's your base assembly. There's your conversion module connected by cables to a rack of 8000 IO. It's actually mounted to the cover plate assembly that is hinged and goes on top of this. So kind of in an overview look, here's your 1771 rack of IO with modules, power supply, I believe. I can't quite tell. Yeah, the power supply. Here's your 8000. Here it is after the prototype, after being converted to 8000 IO. It's not the same rack. Here you see the 8000 IO carriers mounted on top on the swing plate, the conversion modules and the cables, and E-BIMs located remotely from the rack. So excellent solution for bringing 1771 into 8000 IO into the T3. Okay, well, I would like to thank everybody for participating. If you have any questions, feel free to contact me. I'd be glad to answer them, or anyone here at NovaTech. If you want more detailed information, get a hold of your account representative, and we can arrange a discussion either online or at your site to talk about what your upgrade needs are. And thank you once again for participating today.